Welcome back, guys. This is the 20th lecture. I'm going in Laplace transform of transients. So now we'll solve one circuit in RC circuit. So this is also circuit given in an assignment. So I'll solve that problem. Twenty ohms, 30 ohms, 20 volts, and this 10 volts. So the question is, the switch is closed for a long period of time. At t equal to 0, the switch is open. Asked expression of I of t or inductor current is there, no? This IL of t or I of t. Ask I of t in Laplace domain or S domain. Okay, so to do this in Laplace domain, we need initial conditions. Okay, so at t less than 0, the circuit in time domain. So this was closed for a long interval of time, and at that long interval of time, the inductor gets in steady state. So at t less than 0, the circuit behaves like this. So inductor is shorted here. So this inductor at steady state, it went at before time. This inductor goes to steady state, I of 0, 10. So the current I of 0 is what, So due to this short circuit, there will be no impact on this 20 ohms of this source. So the current here is I naught. So I naught is equal to 10 by 20, that is equal to 0.5 amps. Okay, now at t greater than 0, the above circuit in S domain. Now this is the main step you need to know. So this inductor having a initial current before switch closed is have. So in right side, you need to represent this inductor having initial current I naught. If we convert this time domain to Laplace domain, this inductor having initial current in time domain is converted into inductor of value Ls, and in series with a voltage source of L I naught. So why I represented minus terminal plus terminal here? Since the current is traveling like this, flowing like this, so the first source, this is the active source, the current should be flowing like this, means the terminal should be minus and plus here. Okay, this is the equivalent representation of an inductor having initial current in a S domain. So replace this equivalent circuit in this here at t greater than 0. At t greater than 0, the circuit in S domain. Okay, so switch is open, t greater than 0, the switch is open, and the circuit in S domain, this equivalent inductor is replaced like this. This is 30 ohms, 20 ohms, and this voltage source, this constant of Laplace is 20 by S will be represented, and this voltage source as a 10 by S. is 0.5 s, and this is L value is 0.5 given, 0.5 Henry, and I naught value you got is 0.5 amps. So this gives equal to 0.05 amps. Okay. Now, so we need what? I of s. So simply by loop analysis we get I of s. The loop equation is minus 10 by s minus 20 by s plus 50 into 10, 30 plus 20, 50 into I of s plus 0.5 s into I of s minus of 0.25 equal to 0. So we need response I of s. So take common of that. 50 plus 0.5 s equal to, take that constant out that side, plus 30 by s. So we need I of s. So 0.25, rearrange that other circuit, 0.5 s plus 50. Take this 0.5 outside and you will be getting 0.25. So 0.5 s plus 0.5 s plus 30 by 0.5, 60. 60 by s into s plus 50 by 0. About 100. So need I of s. So for the getting inverse, to get the inverse of this I of s, we need to apply inverse Laplace transform. So I of s equal to a by s plus b by s plus 100. So I of s equal to a of s plus 100. So as usually we will, for constants we find in this form. So compare this numerator with this numerator. So you will be getting a of s plus 100 plus bs equal to 0.5 s plus 60. So compare the coefficient of s here, a plus b equal to 0.5, and compare the coefficient of constant e of 100 equal to 60. So equating the two equations to get constant a and b, you have value of a equal to 0.6 and value of b equal to minus 0.0. So replace these two elements in here, 0.6 by s plus minus of 0.1 by s plus 100. So inverse I of t equal to Laplace inverse of I of s equal to 0.6 minus 0.1 e power minus 100 t. Okay, this is the method for every circuit, for any circuit. So this is a RL circuit. So we are having a resistance and one RL, one inductor element. So initially what we did to initial condition, initially the switch is closed for a long time. Since the switch is closed for a long time, this inductor gets shorted here. Since at steady state the inductor is shorted, so we find that initial current, initial I naught current means not inductor current, initial current. Here before switch is applied, that current. After switch applied, the circuit will be transformed like this. The circuit will be transformed like this. Okay, this will be removed. Circuit transformed like this. To get I of s, we just give a loop equation. For the main finding this branch here is important here. Okay, so we replace this 0.5 inductor to this form, and we followed the inverse Laplace technique, and we find I of t. So before what you did, just we found I naught, and time domain we find a final current I infinite and time constant. That is the method to find time in time domain, and this is the method to find a Laplace domain. So in the exam you may ask in time domain or Laplace domain. if nothing in any method, if he asks means find I of t after switch is open, it's your choice to find whether in time domain or in Laplace domain. So which method is you feel comfort, you can solve. So in next class we'll solve a combination of RLC element. So RLC element we have overdamped sum. So I will choose a few circuits: overdamped, critically damped, and underdamped. I won't solve same series element series RLC circuit. I combinationally I'll give that circuit, one circuit, and we'll solve that. Thank you.